Lights, camera, action. Okay, $25,000 compounded continuously. For continuous compounding, we use this guy. I didn't label it, did I? A times e to the RT. So the A would be the initial amount, 25,000. The E is the E. What do I put for the R on 19?
3.9 or 0.039.
0.039, we decimal a couple places. And what's the time?
There is no.
Oh yeah, they don't tell us the time. So just put a T in there. I remember that. We'll call it F of T. And then the directions also said, you guys probably forgot, but you're supposed to figure out how much money we have after 15 years. So we need F of 15. Plug in 15 there. What do we get? What do I get?
I got 44,874.77.
Okay, we're talking about money, so where should we probably round it to? 777 or 7?
It's 774.
Okay. All right. Number 20 says write an exponential function. So the exponential function, exponential growth function, is the same thing as the simple interest function. You just put the numbers in there. So 20 is easier than 17 through 19. 21, the half-life thing. I don't think I will put this on the test, but it's similar. Well, since it's an odd, we'll just do it together, and then we won't worry about it. The half-life of radon 222 is 3.8 days. How much of 300 milligrams of the isotope remains after 8 days? So the theory on half-life is, and I say theory because I don't know how you can prove it, but if the half-life is 3.8 days, like after 3.8 days, you're only supposed to have half as much whatever radioactive stuff, I guess. But anyways, so 300 is the initial amount. And then you always multiply it by a half because it's going to go down by half. And then you do the time divided by whatever the half-life is, 3.8 in this case. Okay, so there's a bunch of questions on this one though. I probably should put a P up here. The first question was, write an exponential function, check. The second one is state the growth factor. You guys remember what that meant?
Oh, wait, like
The growth
if it's
factor-
growing or decaying?
Yeah, the growth factor is the number that you multiply by over and over again. It's the parentheses simplified, so it's 1/2. Factor means a number that's multiplied what?
Wouldn't the growth factor be negative half?
Oh, yeah. Well, no. It'd be negative 50% if we changed it. Okay, the percent one was, okay, here's what you're thinking of. Another way I could have written this is like this. This would be like a 50% decrease, right? This would be the growth rate, negative 50%. But the growth factor is 0.5, is 1/2. Okay, so the growth rate is the number that goes right here. These are like 10%, 5%, that kind of thing. but the growth factor is the whole parentheses put together. So usually this is a percent, we write it as a percent. Okay, and what was the next question? And the percent change. Okay, that kind of goes to what we just talked about. So the percent change is actually a 50% drop. So it's negative 50%. And I lost my place. Percent change, then use the function to answer the question. Okay, the question is, how much will we have after 8 days? So, what do I do with the 8?
Plug it in.
Put it in for t. All right, what do we get? All right, they just put it 69.7. If they don't tell you where to round it to, you can kind of just make it up yourself. All right, 23. Convert this to log form. This is where our pace is going to start picking up. We kind of made it through the hard part. You guys remember how to change this into a log function?
AC.
Remember? Yeah, ACB. So ACB. So what do I do with the A? That's the base of the log, the little number down there. A, C, what do I do with the C? The bigger number. And then the B, the exponent goes over there. Same thing, but opposite order, change it to exponential form. So it is natural log of 7.8 equals 2.0541. Okay, again, going both directions, ACB works on this one too. So what's the A on this one? What's my base?
7.8.
No, E. Natural log, there's an invisible E right there. So it's E, then C, what do I do with that? That's the exponent. 0.0541 equals B, 7.8.
Do they just want us to run it that way?
Yeah, right next, this is exponential form, this is log form. We can't solve, it's already solved, we're just changing it back and forth. So we actually use the log stuff when we're solving like equations with the exponent missing. That's when it's actually used, which we're probably getting close to. Number 27. Log base 5 of 1 over 625. Okay. Well, I think I could figure this out without a calculator, but how would I do it with a calculator?
Log 165 over log 5.
Yeah, you said it a little bit off. Log of 1 over 625 divided by, you guys remember this trick? Log of 5 would work. Some of you, your calculators have a base changer, so you could just plug that in. But if you don't, you have to do log of this over log of, divided by log of this.
-4.
Yeah. 5 to the 4th is 625, so 5 to the -4th is 1 over 625. But yeah, you can use your calculator on this. Now, if this was like a test and you forgot how to do it, I'd let you borrow one of the fancier calculators. I'm about out, actually. People took all my calculators. I got one left. Ty, is that mine?
Nick's using.
Nick's got it.
I've got an extra one.
The fancy one with the.
Or you, well, some of you have your own fancy, so, like Ty, you guys, you don't have to ask to take it from Ty, just take it and he'll be cool with it. 29, log base 7, 67. So, Craig, you know what we should plug in the calculator on this one? You know what we should plug in the calculator? Josie assist,
Log base 767.
or what else?
Or, log 67 over log 7.
Alright, you guys actually need to do that, by the way. It's, what does it come out to? 2.1608. Alright. Thirty means, what's the base on 30?
E.
E. E to the what equals e to the negative 5? Or use your calculator, whatever. Okay, 31, 32, we're skipping those. Alright, 33. Expand. What do they mean by expand?
Make it long.
Make it bigger. Yeah, break it apart. That was this. It's been a long time since we did the green stuff, right? These rules. So, if it was x times y, you can break it up into log of x plus log of y. If it was x divided by y, break it up into log of x minus log of y. If there's an exponent on the x, you can move it in front as a factor, multiplier. So, that's what we're going to do. 33 says log base 4. The base doesn't really do anything, just kind of stay the same. So a and b squared are multiplied together, right? So if they're multiplied together, what do we do with the logs? Add. So it's log base 4 of a plus log base 4 of b squared. But what can I do with the exponent? It moves in front as a multiplier. So this 2, I'm not going to write it again. I'm just going to put it right there. You do have to have those memorized. I'm not going to leave this on the board. Sorry. It'll probably be like 2 questions on the test. Huh? What did you say?
Nothing else. I mean, I had another question.
There are no dumb questions.
You'd be surprised.
Just dumb people. Just kidding. All right, 35. Okay, so x and z are multiplied together, right? So I'm going to do log of x plus log of z. And then the y is multiplied also, so we're going to add the y, but square root of y is the same thing as y to the what power?
1/2.
1/2, yeah. Square root's like the 1/2 power. And what am I going to do with 1/2?
Put it in front.
Move it to the front. So all those are multiplied together, so just add them all. Square root of y became y to the 1/2. 1/2 moves to the front. Okay, and then 36 through 38 is the opposite. Where instead of breaking it apart, we're going to put it back together again. Whoa. Okay, so on 37, there's a 1/2 in front of the log. Where am I going to put the 1/2? On the 16 as an exponent. So just the opposite of what I just did a second ago. So this 1/2 is gonna come up on the 16 as an exponent. And what is 16 to the 1/2?
4.
Square root of 16, which is 4. So that first term, I'm just going to write as log of 4 plus log of 4. And then the third term says a 3 on the front. The 3 is going to go up as an exponent. So it'll become log of 2 to the third. What's 2 to the third? What happened there? So that's log of, common log of 8. Alright, when we're adding logs together, what can we do with the numbers? Multiply. When we're subtracting logs, what do we do with the number? Divide. So we're going to do 4 times 4 divided by 8. 2. So it's just log of 2.
What number are we going to?
Where do we get?
I mean, like, in all.
Huh?
No, like in total.
Oh, 53 is what I put. I was feeling ambitious, I guess, when I looked at this. Well, I think we basically did everything in this chapter, so I felt like we probably should do it all. Alright, 39. Okay, now we're actually going to have to solve stuff. So, there's different ways to solve some of these problems. That's what I'm a little bit concerned about. What do you think I'm going to do with that 2 on number 39, the 2 in front?
Put it as an exponent.
Move it up to an exponent. So I'll have log base 3 of x squared equals log base 3 of 25. Okay, yeah. If you have 2 logs that are equal, like log base 3 this, log base 3 this, that means these two things would have to be equal. So basically it's just x squared equals 25. How do I solve that? Square root. What's wrong with my answer? Yeah. Now I just realized the negative might not work on this. Negatives don't work in logs very well. So if I try to put a -5 right here, I guess you'd square it and it'd still work. Yeah, never mind. It would still work. Usually there's not an exponent to save us. Usually, like, this would be impossible, for example. This, if you plug this in your calculator, it'll say error or something. Because 10 to the y equals -10. There's no power that can turn a positive into a negative. Doesn't exist. So, anyways, this does work because the negative is squared, it becomes positive. It's all good. Whoa. Freak it out. All right, 41. This one looks short and sweet, doesn't it? Isn't that sweet? Elena, save us. What do we do?
We put the 2 on top of the x as an exponent.
You could do that. Yeah, I would probably just divide by 2 so I could get rid of it. If you did what Elena said, you would get the right answer. You get 2 answers and the negative wouldn't work because of what I was just talking about earlier.
Extra things.
Huh?
And the negative gets squared, but it still works.
Oh, yeah, you're right, negative 1b squared. Wait,
What's wrong? That's not how you say it.
I didn't say anything.
no, they didn't put the negative, so maybe the negative doesn't, why wouldn't the negative work? I don't know. Maybe the book got it wrong, possible. That's all right, I'm not gonna be picky on that part anyway. So the 2's cancel out, so we get log of x equals 3. Now what? So here's an important point, this will help. If you have a log equation with a variable, usually you have to change it into an exponential equation, girls. If you have an exponential equation with a variable, usually you have to change it into a log problem. So like something like this, we'd have to change to a log to solve. Something like this, we need to change into an exponential equation to solve. So what is this as an exponential equation?
10 to the third equals x.
Yeah, remember if there's no base right here, there's an invisible 10. On natural log, there's an invisible e. Anyway, so a, c, b, 10 to the third equals x. What is 10 to the third? 1,000. Oh, okay, here's why it doesn't work, Justice. Because the 2 normally doesn't make a difference if it's here or here, but if it's here, if you try to plug a negative in right here, that's gonna fail. This is what it originally was, right? So,
That on number 39 too, isn't it?
yeah. Yeah, you're right. So on 39, it was like that too, so the negative actually should have failed on 39. All right, 43. Log base 6. Okay, here's a question. What is inside of this log? Is it the 2x or is it the 2x minus 4 in the log?
2x.
Just the 2x. If they wanted to put it all in, they'd have to use parentheses. Okay, so I want to make this a simpler equation so I don't have all this mess. So how can I clean this up a little bit? The ideas?
4.
Right. I want to get rid of that 4. So if I just add 4 to both sides, now I've got a pretty simple, just a basic log equation. And now that I've got a basic log equation, what am I getting ready to do? Change it to an exponential equation. So what is this as an exponential equation?
6 to the third equals 2x.
Right. You guys follow that? 6 to the third equals 2x. So how do I solve this for x?
Divide by 2.
Whatever 6 to the third is, divided by 2. I believe it is 108. Okay, 45. What's different about 45?
It's an exponential.
Right, it starts as an exponential equation. And if it starts as an exponential equation, what are we going to do about it? Change it to a log. So what is this as a log function? Log base 2 of 18 equals 4x. Okay, remember earlier, we were like plugging this stuff into our calculator, right? So we can do this part, it's some weird number that we can find with the calculator, but how do we solve for x? Divide by 4. So whatever this stuff is, like you can use the change of base, or you can do log of 18 divided by log of 2, and then whatever that is divided by 4. Are you guys playing baseball? Ty? I wouldn't think you'd have a choice. Luke, you playing?
No.
Just you two guys? Do we have enough? Girls do anything?
Still playing volleyball.
Volleyball? Well, you guys are playing league. We don't have a team here, do we?
No.
Well, we've had one before, and we just didn't have enough
Everybody
girls.
plays volleyball for like a long time.
Yeah.
I don't think we'd be good enough for Selena though. I think Selena would like.
Selena
be
would
so much
dominate.
better than the
Alright.
others.
47. We might actually get done with the odds. Okay, so my revised plan is tomorrow I'll let you guys work on the evens.
Alright.
Friday I'll make a worksheet to help us some more, and then Monday we'll review it again. We'll like talk about the test, and then Tuesday we'll take the test. So fun times ahead. Alright, number 47. The junior's gonna be going. Are you guys going on the trip?
Yeah, I'm going.
Jordan going?
No,
Me? Oh, no. Oh,
she's not.
You guys are gonna start this here. 47.
We're gonna start a riot in DC. Just move, yes.
Probably not a good idea.
Nah.
They're kind of touchy in DC. PC.
I wonder why.
Oh no, 47 is that problem that I didn't like.
She's not that one.
Yeah, we could just skip
Make
it.
it fun. Kick common logs and
Yeah,
You don't like it, imagine how we do.
you don't even know how to do it yet.
Exactly.
Yeah, I know how to do it, but it's like 7 lines, and it'll probably just make you guys depressed. So let's just go on to 49.
Are we skipping that one?
Yeah, none of the evens are like that, so you don't have to worry about that. 49, 2 x equals 7. All right, any ideas? Yeah, if this just said e to the x, we could turn that into a natural log, right? So I want to get rid of the 2 over here. So I'm going to divide by 2. So e to the x equals 7 halves. Now we got a basic exponential equation. So what's my next step?
Natural.
Change it into a log. In this case, yeah, it's log base e of 7 halves equal x, but log base e is just natural log. And you all should have a button on your calculator that says, well, actually, not that one. It does?
Yeah.
Oh, I'm surprised. So you just hit that.
Yeah, but it's like weird.
Where's it at? Thought I looked at that one earlier. Didn't see it.
Texas, but it's still so.
Do you want us to round to the thousandths?
They put 1.253, yeah. Yeah, the directions did say the thousandth place.
I did that. Yeah. You can do it. You sent it.
Yoink. 51. Okay, an SUV has lost 1/5 of its value each year. If the SUV is valued at $7,400 after 5 years, what was it originally worth? What kind of function are we going to use?
Interest.
Exponential growth. In this case, it'd be exponential decay, I think we call it. So, yeah, we're missing, how much was it originally? So we're missing the A value. Let's go Y equals A times, okay, it says it's supposed to decrease by 1/5 each year, so what am I gonna put it in here?
1/5.
No,
One plus 1/5.
1 minus 1/5. Or a simpler version would be, what's 1 minus 1/5? You have 1 cookie, you eat 1/5, you're left with 4/5. Yeah, if you lose 1/5 of what you had, then you're gonna have 4/5 of what you had. I don't know if that makes sense. Wait, what? How many years did it say?
5.
4 or 5?
5.
5 years, and it's supposed to get to, lost my place, $7,400 is where it ends up at. I'm gonna erase this Y, I don't need that. Alright. How do I solve for A?
4/5, 1/5, which is.
Okay, this is just one number that is multiplied to A. I don't know what it is, but whatever it is, it's something multiplied to A. So we just need to divide 7,400, divide by that. Okay, well, whatever it is, 7,400 divided by that would give us our magic answer. Should A be smaller or bigger than 7,400?
Bigger.
Bigger, because it's dropping by 1/5 to 7,400 every year. Didn't plug it in yet.
Is 50 the same formula?
Yeah. Anytime you're having an exponential growth or decay, it's gonna be this guy.
You could buy
Compound interest is that one.
22,583.
Okay, they
On
stopped
the
right.
dot.
They stopped right. It really was right on
I
the
think it's
dot.
one.
Oh no,
One
it's
cent.
0, then it's
Okay,
0.00.
well, they just put that. They just put that, so. Money.
Then round.
Money, 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 money.
You think you're gonna buy an SUV?
Oh, shoot, 52 is a half-life. Okay, I'll help you set up 52, and then we'll do 53, and then we'll call it good. Perfect timing, I think. All right, plutonium is starting with how much? 50 milligrams? Yeah. Right. Oh, it's a little bit different though. Okay, starting with 50 milligrams. You guys remember how I set this up on the other one? You do times a half, then you do to the t divided by the half-life, which is 6537. And they want it to get down to 40 milligrams. Ooh, what a messy problem. Alright, what do you guys think I should do first? Yeah, I want this to be simpler over here, so I want to get rid of 50. So divide by 50.
4/5.
So, yeah. 40 divided by 50 is like 4/5, or 0.8. Okay, now if I have an exponential equation, how do I solve it? log. So log base 1/2 of 0.8 equals t over 6537. And then, so this part we use our calculator on, and then what's our last step?
Divide, multiply, multiply.
Multiply the 6537. Okay, this was actually 52, not 53. It's not quite done, so you guys do need to finish that. Josie, are you meditating?
I wish, huh? Standing there and looking in the window.
You're staring at me?
Wow. Scary.
53, First Faith Baptist Church wants to invest $15,000 in an 18-month account that pays 4.6% APR percentage rate, compounded continuously. How much money will the church receive upon maturity? Okay, so which formula are we going to use?
Compound.
No,
The other one.
continuously. So this one that I didn't label down here.
What's the name of it?
Continuous compound. I don't know what's called.
Yeah, fire.
So the initial amount was 15,000. That's our A value. Times E. What's the R? What's the rate? 4.6%, which changes into 0.046. And what's the time? 18 months. How many years is 18 months?
1.5.
Yeah. There's 12 months in a year, so it's, 1.5 years, 1.5. So that'll do it. They got, what'd you guys get?
1,600.
16,000.
$16,071.54.
Oh, you.